Yeah, hi everyone. So today we are going to talk about two different perspectives on ETL or ELT, if you want, process, and we're going to discuss machine learning perspective and data engineering perspective. So I will be talking about machine learning perspective, a little bit about me. My name is Violetta. I started as a data scientist in Nokia R&D. I worked there for 4 years. Mostly I was like training models, both classic ML and neural networks. Then I moved to MLOps engineering and worked on ML tools. And finally, half a year ago, I joined dltHub, which is a company which is working with data engineering. And what was surprising for me is that both machine learning people and data engineers work with data, work on data pipelines, ETL, but they talk about data really differently. And I had to learn a couple new terms, and it was really funny at the beginning when our users, mostly data engineers, were asking me, hey, is your library working with data contracts? I'm like, yeah, it's working with data. What do you mean? Yeah, but I learned these terms like schema evolution and semantic layer and stuff. And what I now think is that ML specialists could learn a couple thing or two from data engineers. As an ML specialist, you probably heavily rely on tooling. Like, you don't want to implement backpropagation from scratch. You just use PyTorch, right? And if you work with data, especially if you work with structured data, time series, tabular data, you probably use a lot of Pandas. And this is default tool for transformation, right? I also used it a lot. And I use Pandas for all data-related stuff, like for loading data, for memory management. At some point, you discover that Pandas can load data in chunks, yes. Then nesting data, cleaning data, for transforming time series, and Pandas especially good with time series. Verifying data quality, checking the data against known schema, incremental loading and stuff. And it works really, really good, especially when you're prototyping, when you need to test your hypothesis really quickly, get test results, and you work in local environment. You have all your data in local machine, your Jupyter notebook in local machine, works pretty fine. But when we go to production, it becomes a little bit more challenging. And let me give you a couple of examples of such challenges. So if you work with semi-structured data, usually it's data from APIs, or it could be JSON which you receive from Kafka topic or something, you would need to manually understand the schema of the data and unnest it. You need to write this code, and it will take a lot of time. And especially when your data will change, and it will change, you will need to debug it for hours. Pandas does not have support for automatic unnesting. Yeah. Speaking of data changing, when your model is working in production, your data will eventually change at some point. It could be changing distribution or schema, and you need to know this instantly because you want to retrain your model or do different pre-processing. And if you want to do this, you need to either implement it manually or use different tools than Pandas. Another thing, when you're moving to production, you usually move data around a lot, like for your CI scripts, for your model training, for model testing, and you usually use Python scripts. And you need to connect to all these entities, and it could become quite messy. Memory management, my favorite. Probably at some point all of you had to explicitly call the garbage collector, and yeah, Pandas using a lot of RAM, and sometimes it's not enough to load data chunk by chunk. You need to have more control over memory. And the last thing I'm going to talk about is incremental state. So incremental state or incremental loading is another fancy data engineering term, which basically means that I want to load only new data with new timestamps. I don't want to reload all the things. So I need to keep track of the incremental state. Pandas do not support this out of the box. And it's especially useful for your data pipeline resilience, because if connection breaks in the middle of your load, you don't want to load it from scratch, right? So all things said, we discovered that maybe Pandas does not cover all our needs. It's still really great tool for a lot of things, but probably not all. And this is just a tip of an iceberg. And here my colleague, Adrian, will tell you about data engineering perspective. Hey.
Thank you, Violeta. So I'm Adrian. About me, I've been working in data for 12 years now, 5 years in startups, building data warehouses end-to-end, 5 years freelancing and consulting, doing what we call build and hire, so building a data platform and then hiring a team for it. And for the last couple of years, I've been working on building DLT. And my guiding values are simplicity, transparency, and learning, which I also apply in my work. So from my perspective, you know, the part of the issues that are coming between ML people using Pandas and data engineers building their types of pipelines are from the different roles that these people have. So for example, a data scientist will experiment, they will discover, they will explore, they will try, they will validate. While data engineers scale, they make things efficient, they dry the code, they re-implement things to be resilient, they defend it with tests or data contracts, and they maintain pipelines. Second issue, there's actually a lot of technical complexity to data loading that is not apparent when you're a junior. So usually once you've been doing this for a few years, you've encountered all kinds of issues. For example, the pipeline might break on a schema change or on out of memory, non-deterministic loading. Network issues, it will break on the last request from a long chain. Or you might be loading JSON as string. You might be loading everything as string. You might have 40,000 lines of JSON extract spaghetti in SQL. You might have the same thing in Python, and then you have mystery JSON parsing in Python. You don't know what that is, but you have to maintain it. Of course, if type changes, schema changes, so your pipeline will break. You have race conditions when migrating schemas if you have a data loading pipeline and a schema in the database. Data analysts write all kinds of funny things like 300-line methods called main when they could be reusing some code. And of course, all the data pipelines are just a little bit different, so they get you when you try to fix them. And then you have the silent killer when pipelines fail successfully and you can't even tell testing in production, right? So how do you close the gap? As Violeta was saying, there are lots of dev tools for ML, but actually for data engineering, you don't really have much. So wouldn't it be nice if we had a tool that was a dev tool for data engineers so Python people can just use it? Like a Pythonic tool that you don't have to learn up front. So they don't have to rewrite all this boilerplate code all the time that keeps breaking. So yeah, that would be nice, but the requirements are not simple, right? We want to be able, first of all, to manage schemas. We need to know what data we're loading. We shouldn't have surprises. We don't like surprises. Data should be auto-normalized and typed. So when we go from complex JSON to flat tables, we want that to be clean and easy. Loading should be atomic and important, so when things break, it's easy to fix. The incremental states should be persisted. Extractor concept should exist, so when I'm doing all these API calls, I can do them in the same way, and I stop reinventing the flat tire. Loaders should be able to talk to the incremental state and the extractor, so everything needs to kind of work together. We need memory management, we need parallelism. And it should, of course, be easy to develop on local because that's where we're developing. And then when we go to production, things should be kind of the same, right? And of course, we want, you know, resilience and retries, which is something basic that we all do. So why don't we start with Pandas? Very good question. You could think, okay, why don't I start with Pandas data frame to SQL and go from there? Well, first reason is it might be a little inefficient. Second reason is, you know, you have all kinds of complexities. So let's look at what it would take to build a complete data engineering pipeline from a Pandas loader. So let's say we start with a nested JSON. If we want to load it with Pandas, we'll have to take that JSON, normalize it, unnest it, flatten it, and load it. That's fine. Now, if we want our loading to be atomic, so when the loading breaks, we don't end up with half the data loaded, half the data not loaded, and then it's kind of a pain in the behind to clean up, we need atomicity. So we need to tag the data, we need to have a rollback strategy. We want idempotency, so if something breaks, we can just rerun our pipeline. We want memory management, so we stop running out of memory, because when you run out of memory, you might be actually killing all the workers that are also loading other pipelines. We want to have incremental extracting and loading. For that, we need the incremental state storage. We need to capture that state, inject the state into the extractor. It's starting to get complicated. We want to add incremental loading. So like different merge strategies. So for example, we want to be able to upsert the data, or we want to historize it through a slowly changing dimension. For that, we would need to add that materialization logic. Now, let's say we want to standardize the way we extract data. We need to create some kind of extraction helpers. We want to make it efficient and scalable. Well, we need async, we need parallelism. We should be able to easily leverage them. Of course, we want schemas, so you know what they say, I don't always use schema. Oh, yes, you do. Whether it's schema on read or schema on write, you're using it. We need a normalization engine because, you know, sometimes we have strange column names, we have, you know, we don't want to manually type data and all of that. We want to recursively unpack this data, flatten it to tables, create join keys. Then we want retries, right? So pipelines will break. They will break all the time. So you want them to be resilient. Then finally, schema evolution. This is probably the reason why most pipelines break all the time. Whenever you have schema changes, yeah. Finally, you know, sometimes your data is not coming from a transactional environment. It might be events. Maybe some people are sending it randomly from the internet. You probably want a data contract. So you need to build a data contract engine. You want governance. You want to know where the data is coming from and where it's ending up. So you need to have some kind of start for lineage, for example, debugging data quality issues, or simply keeping track of personally identifiable information so you can be compliant with documentation. So finally, you know, when you've built out all this pipeline, as you can see, it gets quite complex. Why the hell are we using Pandas at this point? Unless it's really the piece that comes together really well with all the other pieces, then we probably don't want to use Pandas. It's actually quite easy to just insert some data. So how would we load this data with DLT? Well, it would be a lot easier. DLT, data load tool, it can take a generator, it can take a JSON data frame or DLT source and just load it, basically.
It's my turn again. So yeah, as you probably guessed, we both work in dltHub and we both work on DLT, data loading tool. This is an open source Python library, emphasize on open source, you can use it. And what it does, it loads data from any given source, you can see them at the right, to any given destination at the left, vice versa. And along the way, it will automatically extract schema, normalize the data, and integrate with the destination. And this is my favorite. I don't need to know how to connect to S3 or how to load data to Snowflake. DLT will do this for me. So what do I mean when I say that DLT normalizes nested data? Let's assume we have a JSON. Inside, we have like a parent, Alice, and a list of children. So DLT will understand this is nested data and will provide it with two different tables for parents and for children. Moreover, it will connect them through ID. Basically, this is like join keys, which you can use if you want to join table together back. So why DLT? It's really easy to install. Pip install DLT and go. It's easy to use because learning curve is shallow and it's Pythonic. You don't need to learn any new framework or any new language. So the other thing which I really like about DLT as an ML engineer, that it was built by really experienced data engineers. So if you just work with Python and you don't have a lot of experience in data engineering, you can build pipelines on senior level. And what are those best practices? First of all, schema evolution. If your schema is changing, DLT detects this automatically and just updates the schema. Moreover, you can use data contracts, so you can tell DLT what to do with this data. If we say evolve, then no constraints, data changed in source, data would change in destination. We can say freeze, so if the new data is not fit to the previous schema, DLT will raise an exception. You can say discard row. In this case, DLT will just throw this row which is not fitted to the schema, and and you can say discard value. Incremental loading. So we briefly talked about this. It's a crucial concept because you don't want to reload entire data set. You want only to load new or changed data. This is implemented in DLT. You don't need to implement it manually. Just use it. And DLT has a lot of different things for performance management. Parallel execution, async execution, you can control memory, and you can scale your pipelines, basically. So apart from that, DLT is an open source Python library. It also provides you with ecosystem. So what we have is verified sources, which is basically integration with most of the used sources. Any SQL databases, a lot of REST APIs, something which is just like highly usable, Google Sheets, Notion, HubSpot, GitHub, Slack, a lot of them. We have 16 different destinations: DuckDB, Snowflake, BigQuery, Postgres, etc. And if it's not enough, you can build your own destination with reverse ETL. And also, DLT is heavily integrated into modern data stack. It's integrated with dbt, with Airflow, with Dexter, different things. And if this is still not enough for you, then you can build your own verified source. And to illustrate this, I have here this plot, which is basically showing how many custom sources were created by community. And we track it through telemetry, so it's like rough numbers because a lot of people turn this off. So it probably 5 times more something. Yeah, so enough of me trying to advertise DLT. Let's look at some code and deep dive. If you are still alive, guys. Let's assume that we have API with crypto data, and it's not supported by verified source, by ecosystem, so you need to build your source yourself. Let's see how easy is that. What we're going to do, first we're going to create a DLT resource. It's just a function which calling to API and yield list of tokens. Then we're going to build DLT transformer, which another type of resource. And what it does, for each token in the list, it will call another API to get additional data. Then we combine them together in one resource. This is DLT, in one source, sorry. This is DLT source. And then we use pipeline run to load data to destination. So both resource and transformer will generate at least one table each. Then source will generate a data set consisting of several tables, and pipeline run load data set to database. One important note here is that DLT decorators use yield to produce data on the fly, so you won't run out of RAM. This is how code looks like. So you have like decorator dlt.resource, which is function which yields a list of tokens, as I said. Then DLT transformer, which takes data from the coin list resource, and then call API for each record in this list. Then we just combine them together into one source, crypto data we call it, and run the pipeline. The whole code looks like this. Of course, instead of 3 dots, there is like a request library calling API, but it's like quite small and convenient. We have here resource, transformer, source which combine 2 resources together, and then pipeline. We define pipeline, we define the name of pipeline. The destination here is a Postgres, but you can change it to, I don't know, Snowflake, BigQuery, anything you want. And then we just run this pipeline. So as a result, what we get a lot of tables in our Postgres. First 2 tables are pipeline metadata. It's where DLT keeps some information about incremental state, which I mentioned earlier, about loads, about version of the load. And other tables are relational tables from nested data. You can see coin list. This is from coin list resource. Coin information. This is from coin information transformer. And all other tables are actually automatically extracted, automatically unnested. They're like children tables. Yeah. So the cherry on top. First of all, DLT is a library, it's a Python library, so it runs anywhere where Python runs. So if you have like your infrastructure with Airflow or Dexter, you can run DLT there. It's open source, so go to GitHub, give it a star, please. So you don't need like licensing, you can use it in your work, in your pet projects, in your product maybe, if you want. It has quite extensive documentation. We constantly work on this documentation, and we actually have an amazing community in Slack. We have more than 1,700 users there, and you're just welcome to join and ask any questions regarding DLT or data engineering or anything you have in mind. Also, DLT is really good on lowering and cutting the cost. For example, this is one of our users who replaced like famous cloud provider with DLT, and they saved money from 6,000 euros a month to 45 euros a month, and only because they need to pay for AWS Lambda, because yeah, DLT is free. Yeah, so that's probably all. Check out our website, join our community, and give us a star on GitHub. Thank you. If you have any questions, you're welcome to ask them right now. Sorry, it's your line.
Yeah, so they are open for questions now. You can walk up to the microphone and ask them. Thank you.
While you're thinking of asking questions, we also have a booth there, so you're welcome to go and ask us directly. And yeah, I see a question.
Do you use images as a source of data?
We have a source which called file system, which basically works with like a lot of different data. Images, you can use it as well. And for example, for metadata, you can use DLT directly to extract them and store in SQL databases.
Can you extract information from point by point, pixel by pixel?
No, in this case, like images would be just like loaded to your destination. For example, if you need like them to be in S3, DLT will just take this image and load there. But with metadata, it will do the unnesting and other stuff. You can also comment. Because yeah, please, yeah.
Okay, you mentioned that the metadata table is stored at the same place where all of the other data is stored, right?
Yes.
So is it possible to configure the metadata tables to be stored somewhere else? And how configurable are these?
So actually this one not, but you know, we recommend a loading pattern where you're loading your data to the raw layer, you use schema evolution, you notify that to the analysts, and then the analysts will promote this data to the staging or to the production layer. So this shouldn't really interfere with anything.
Yeah.
So basically you're not recommending that this is like finished data for analysts, they should check it out further.
You can use it as a finished data set, but usually you need to model it because usually you have business requirements and business analysts that need to do pivot tables. So to do that, you need to create a fact and dimension model like a star schema, so you need to work with it.
Thank you.
So actually my question was, would it be possible to somehow customize like to which extent the data will be unraveled? For example, if I don't want to create those additional relations or just store them in, I don't know, JSONB field or array field or something like that.
Yeah, we actually have several ways to do this. Like on the level of resource, you can just create like column hints. You can say, okay, don't unnest please this column. I need it as a complex, as a JSON, for example. And you can also import your schema if you have it from somewhere, or like only define it for some tables or for some columns. DLT can work with this too.
Okay. Thank you.
Thank you.
My questions are about integrations with other tools. So if so you said that it can integrate with things like Airflow. Where would DLT end and Airflow begin? I mean, could you use, so DLT wouldn't handle any kind of scheduling, anything like that, but it does a pipeline, so like, does it have any kind of monitoring built in, or would you have to rely on something third party to monitor it?
The idea about DLT, it's a really good question. You can drop it in anywhere and it should be able to function without the, special orchestrator features. So I would say where DLT ends and Airflow begins, you can just run DLT locally off of Airflow. So, you have a nice development flow. And when you go to Airflow, like Violetta was explaining, you have resources, you have transformers, so you have some dependencies. And you can actually unpack these in a DAG. We have a deployment helper, so you can choose parallel unpack or serial unpack, stuff like that.
So then would it be like your DLT pipeline is a task in your DAG, or, okay, cool.
Exactly.
Yeah.
Right.
Yeah, cool.
Hello, thanks for the talk. You mentioned data lineage as well in the presentation. So how much of that is supported out of the box?
So the lineage is available for loaded data. You get basically just some information. When did this column appear, what table, and so on. And then it's a little bit up to you what you do with it. So for example, we have a user that is handing this over to SQL Mesh, and they have complete lineage there. We have another collaboration with SDF, Semantic Data Fabric. There we tag PII columns, and then they handle the documentation.
So just to follow up on that, so what sort of format is that lineage stored as?
Sorry?
How do you actually, how that lineage is accessible? What's, what format is it stored in?
So the lineage information can be obtained. Basically, there is something called load info that you get back when you run a pipeline. You can load this load info back, and then you'd have that information either in tables, or you can use it directly in Python. And I think, yeah, for the semantic tags, we're actually, so DLT infers a YAML schema of the data, and then you can do things on the schema. So you can put PII tags, and then these can be read by something else.
Okay, yeah, thanks.
Thanks a lot. If you don't have any questions, then thank you. As I said, go to GitHub, give us a star, check out DLT. And also we have an after party on Thursday if you want to come after the official event. You're welcome.